We're going to start this lecture discussing, I'm sure, one of your favorite topics. It is mine, Lewis structures. So connecting all those little dots around the atoms. So I'm going to go about it, I don't know if it's a different way, but my way. I'm going to give you a series of rules that we're going to kind of go through to decide how to put these things together. First step is to add up all of the valence electrons for all the atoms that are going to be in this. Okay, once we have that, we will draw the structure. As a rule, the least electronegative element is in the center. That is the central atom. So again, just to remember using this, the least electronegative atom. So again, if this is the most electronegative, somewhere in this direction, somewhere down. So away from fluorine. Fluorine will never be the central atom. 3, you will draw octets, 8 electrons, around all the atoms on the outside. Now don't forget that the line that connects that atom to some other element is a pair of electrons too. So 6 other electrons, dots, and the line that connects it to something else. Now don't forget that hydrogen, it has a full shell with only 2 electrons. So 2 only on hydrogen. And if you're connecting to something, that's the 2. It doesn't get any more. Now I know this is a mistake that a lot of people will make, is they just start throwing electrons all over, and sometimes they get 10 or 12 or however many electrons. They can only have 8 electrons anywhere on the outside. There are a little bit of exceptions, and I'll come to that shortly. And here's part of it. If you have extra electrons, you can put some on the central atom. Not everybody can do this, but some central atoms can do this. So extra electrons, say you have 2 extra electrons, that can sometimes go onto the central atom. Usually, sometimes, it has to be something higher than energy level 3. So I'll say 3 or higher energy level. And some examples of that would be sulfur, phosphorus, arsenic, antimony, and yes, even occasionally, xenon. These guys sometimes can have expanded octets. All right. Rule number 5, or step number 5. Multiple bonds, if needed, to lower electrons. And we'll see how this plays out later. That doesn't completely make sense. That if you have extra electrons, there's no place to put them, you can actually start forming multiple bonds, double bonds, triple bonds, and that will use up pairs of electrons. Again, we'll see how this plays out. Let's do a quick example. I believe this is called arsenate. Arsenic is the central atom. And if we take a look over on the periodic table, we have to figure out how many electrons, valence electrons, that arsenic has in oxygen. So if we take a look, here's arsenic. It is below nitrogen. So to figure out how many valence electrons it has, if we start over here, so 1, 2, skip this whole section, 3, 4, 5. Arsenic has 5 valence electrons. And we'll do a little inventory here. Arsenic, there they are. It's got its 5. Oxygen. Now oxygen has 6 each, so we'll do that really quick. Showing 1, 2, skip this section, 3, 4, 5, 6. 6 valence electrons for each oxygen. I've got 3 of them. So I got a total of 18. And then I have 3 extra electrons from here. So it has a 3 charge, negative. If we add this whole thing up, it's 26. Now at this point in the game, you may not know how to structure these things, and that'll just come with time. But based on the rules that we have here, the central atom is the least electronegative. That is arsenic. And then we just start sticking these guys on to arsenic. Oxygen is rather electronegative, so many times it's trying to hog up more electrons onto itself. We'll ignore that. We don't need to worry about that right now. But now we're just randomly just going to start throwing on electrons to get everything up to a total of 8. Don't forget that these lines are 2 electrons. I'm not counting, I'm just putting them on there. Okay, I've given everybody 8. Now I'm going to just count and see how many I have. I would like to have 26. And again, these are electrons. 2, 4, 6, 8, 16, 24, 26. That's exactly what we need. Now, one more thing for this particular one is the fact that this is an ion, this is a polyatomic ion. We're going to put these brackets on here. You do need to do this. And put 3 minus to signify that this compound is actually holding 3 extra electrons. This helps explain why is this an ion that has 3 extra electrons. It satisfies the octets. Again, these guys have high Zeph, and therefore they attract electrons really well. They're electronegative. They attract electrons. It works out pretty well. All right, let's bounce over and do a homework problem or two. If I can find them. 47. So we got a whole bunch of these. I don't know if we'll do them all, but we'll do a few anyways. The first one here, silicon tetrahydride. Silicon is the central atom. Well, I guess I should go through and do the electrons first. For silicon, it's got 4. It's count over 4 rows, just like carbon, or columns, excuse me. Hydrogen has 1 each, so I have a total of 4. There is no charge, so I need to come up with 8 electrons. Put all these hydrogens in here. Two, 4, 6, 8. Done. Let's do carbon monoxide. All right, so I've got carbon and I've got oxygen, and you will erase occasionally, so don't get too comfortable. Don't do these in pen either. Okay, sitting here, I didn't even count. Let's go ahead and do that first, or second in this case. 4 electrons for carbon and 6 electrons for oxygen. Gives us 10 total. That's how many I should have. 2, 4, 6, 8, 10, 12, 14. Ugh, too many. So just like the rule we pointed out a second ago, multiple bonds if needed to lower the electrons. Okay? I don't know if that was visible or not. Multiple bonds are needed to lower the electrons. Okay. So I only can have 10, but apparently I'm sitting here with what was 14. I'll try again. 2, 4, 6, 8, 10, 12. Still too many. Let's get rid of these guys. Okay. Put a third line. This is as far as you go. You can't have a quadruple bond. That's just ridiculous. But 3 bonds is fine. 2, 4, 6, 8, 10. That's how many we need. Now, just to be clear, each of these guys should have an octet. 2 electrons, 4, 6, 8 electrons for oxygen. 2 electrons, 4, 6, 8 electrons for carbon. They are sharing them. These bonds are covalent bonds, which means they're sharing them. So they have them, carbon, and oxygen has them as well. This works out. Perfect. All right, that's a good place to take a break, and we'll go on to lecture number 3 shortly.